Hello, my name is José Pedro, and I'd like to show how we can, for example, get some outputs from nastran, the software for the FEM, finite element method, and then we can have this output data. And after that, we can post-process this data by using paraview. This is a very nice resource because paraview has the potential to post-process like a lot of types and kinds of data, and it's possible to post-process data, for example, in a by using CSV files, by using, for example, velocity fields from fluid mechanics solvers, and also for things concerning structure, for example, the strain. I'd like to see the strain in paraview, for example. So paraview is a very nice and results very nice tool to visualize things. So uh, let's start here. So imagine that we run a simulation on Astra, and we have some output files. Okay. Here we have the repository, uh, and in this repository we have this script. By using this script, we will be allowed to have VTKs files, and these VTKs files are the files that the paraview will use to open and to visualize your data, and then we can put filters and analyze your data um, as much as possible. And then, okay, so first of all, imagine that you have some outputs files from nastran. Uh, so we have here, for example, we have two simulations here, and we'll have, let's go to this duct steel here. So here we have two files from nastran. The first file is steel point BDF. So this BDF file concerns exactly the geometry of our structure. So our circular duct is uh, is described here in this file here. And then we have another file, which is the steel point OP2. So here we have the model analysis here. Here we have the modes of this duct, and then by using this file we can analyze the data and so on. So now the question is, how could we open these files on paraview? First of all, we need to do this following conversion. We need to convert these two files uh, into a VTK file, just one VTK file. In order to do that, what we need to do? So we have this code here that I showed you previously. We just copy and paste here. Okay, that's fine. And then After that, we need to install the requirements here uh, of this code. So this code needs, for example, nastran, needs VTK, needs some libraries to run what you want to run, etc. Which is this code here. So have some libraries that we can start here, and then in this list we just need to do like a pip install space dash r requirements, and then we'll have all the packages here installed on our system here. Okay, that's perfect. So we have the file here, and then we just need to run this file here. We run in the following way. We do Python 3, okay, and then the name of the file, export to VTK, and we need to put the name of our model here, which is still. We just need to put still, not point .bdf or point op2. It's just still, okay? And then we just write is still, okay? And then enter. And then we'll have this following message here. Finished exporting. We'll have a new file created, which is called still.vdk here, which is very nice. So now we just need to open paraview here. Okay, this is like the normal paraview here. And then let's open the file here. So in order to open, I can just put the path here, okay, copy and paste here, navigate, and then we have my still file here, so which is exactly this file here. So have all the points here. Very nice. So we just do it and then apply. And after that, we can see our circular duct here, which is very nice, super cool here. And then we can see the modes. This is very interesting here. The modes that we have here, we here on the left here we have the options of the mode that I want to check. For example, I want to check the mode 9, which is this guy here. So this is very nice. This is super cool. And then we can, for example, apply some filters here. We can, for example, animate the mode. So let's go to the first mode here, okay? So this is the first mode here. We have the deformation here. And then we just go in filters, alphabetical. We can have, for example, animate modes. Let's go here. And then we just choose this first mode, okay? And then we apply. So what's happening is exactly this one. Here you have the deformation of the mode here. So since that we have the direction here of the deformation, along with that we have exactly the strain here, the strain, the magnitude of the strain of this duct here, which is very interesting. And then if you want to animate, we just play here, and then we have the animation here of this mode, which is very nice. Okay, so I hope this tutorial can be useful for you in some way, and see you soon. Ciao ciao.